So let's look at these two example problems and try to do them as efficiently as possible. So this first one, if we pretend like this is an equation, then any of those factors could equal 0. Meaning the first factor of x could be 0. If x minus 6 were 0, then x would be 6. If x plus 2 had been 0, then x would be negative 2. We're going to plot those three values on the number line of negative 2, 0, and 6. Each of these are done with open circles because the original problem did not allow equality. Now I'm going to pick a test value from one of those intervals. I don't care which one. Because I don't care which one, I want to pick an easy value that's easy to plug in. Ideally, I'd like to plug in x equals 0. In this case, I can't plug in x equals 0 because x equals 0 is one of my border points. So instead, what I would test is I would test x equals 1. So I'm testing in this interval here between 0 and 6. So when I plug 1 in to each of the parentheses, remember that I don't really care about the value. I care about the sign. Is it positive or negative? So I have positive, negative, positive. With only one negative in there, the whole thing is negative. And so then I say, is a negative smaller than 0? And the answer is yes, that's true. So this interval should be shaded because it results in a true statement. Now, if I look back to the original problem, none of those parentheses had a square on them. So this is going to alternate. Since the interval I have in yellow is a yes, the ones next to it will be no's. The next one after that will be a yes. So it goes yes, no, yes, no. It alternates. Yes, no, yes, no, yes, no. Once I know what's shaded, I can write the interval notation. It goes from negative infinity to negative 2, and then the interval from 0 to 6. And that's the actual answer that I care about. Now, the other example we're going to look at the same time is really just as simple. It's just going to have fraction endpoints, but I don't really care as long as I put those fractions in the right place. I need to say 6x plus 7 could equal 0, or 7x minus 12 could equal 0, giving me negative 7/6 or 12/7. Those are ugly fractions, but I don't care where we place them as long as I place them in the correct order, meaning the smaller one is further to the left. Negative numbers are smaller than positive numbers, so there we go. They're both open circles because of the fact that the original problem did not allow equality. And so now as we look at this, we just got to pick 1 point from one of the intervals. And as I was saying on the other example there, anytime we can pick 0, let's. It's easy to plug in. 0 is in between the negative and the positive. If I plug 0 into the first parenthesis, I get 0 plus 7. That's a positive number. In the second parenthesis, 0 minus 12 is a negative number. Are negative numbers bigger than 0? No, they're not. So we're not going to shade that middle region. Now, neither of those factors up there were squared, so we are going to alternate yes, no, yes, no. So that means we're shading from negative infinity up to negative 7/6, and then from 12/7 to infinity. And there's our answer.